Hello, my name is Helena Lindqvist and I welcome you to this introduction video of the European Collaboration Network for Interoperability Testing. Interoperability is a critical factor in the digitalization of the energy sector, and harmonized technical standards provide the key to cost-effective system integration. Our collaboration network is your gateway to interactive knowledge sharing and co-creation, dedicated to advancing interoperability in Europe's energy sector. We invite all projects and stakeholders to join us for peer-to-peer interoperability testing of ICT systems. Remember, interoperable data exchange is just one piece of the puzzle. To achieve true digital interoperability, you must address all the 4 layers, as outlined in the European Interoperability Framework. In this video, Angela Berger, our expert, will guide you through this journey. You will learn about a versatile methodology ready for deployment in the energy sector, driven by cross-sector transfer of knowledge and experience. The future of digital interoperability is here.
I welcome you to my presentation. My name is Angela Berger. I'm from Austria, where there's a lot of experience with interoperability in the healthcare sector. For about 8 years, I've been one of the drivers to promote the knowledge transfer from their good experience in healthcare into other sectors like the energy sector. In the next minutes, I will introduce you a process chain to achieve interoperability in digitalization and how to carry out interoperability tests. First, I will talk about communication infrastructure. Then I will introduce you to the process chain for interoperability, and I can offer you an example for a practical implementation of the process chain. Then we are ready to talk about interoperability testing. Interoperability is a matter of data model, communication infrastructure, and a governance that sets the rules for data usage. So what are the necessary requirements for the data communication in digitalization? We have our actors and market participants. The established ones and new participants will appear in the future. Today, they all collect their own data, but due to the missing interoperability, there's not very much communication among them, and they all do optimization for their own business. In an integrated energy system, all participants have to be connected. The question is, how could this be done in an efficient way? The first approaches were central data hubs. The idea was that everyone should store their data in a central data platform, and new business models can collect the necessary data from the central data hub. It looked as a cheap and easy solution at first glance. But that means to give up data sovereignty of your own data. The moment you store it to an exchange platform without a defined governance, you cannot be sure what happens to your data. Therefore, this option is not possible for critical infrastructure. We have to find another way for data exchange. Another approach is to keep the data decentralized at their owner and make a joint communication infrastructure, which ensures identification, authorization, and security, like encryption, as a part of a common governance. Using this infrastructure, actors can define together use cases that implement them with normative interfaces, where you only receive a defined set of data for a specific use case. Additionally, the joint communication infrastructure can enable cross-sector and cross-border data exchange. As a conclusion, what does this mean to innovation? The functionalities of the ICT systems are innovative. The interfaces have to be normative, and the seamless data exchange accelerates new business models and solutions. To be successful, interoperability must be a European issue. All current European efforts are based on the European Interoperability Framework, where they define 4 levels of interoperability. The first is the legal layer, which describes the legal framework for a specific topic, such as use case. Then there is the organizational layer, which defines the business processes for a use case. For example, when do I get the data? What happens if the data doesn't come or is wrong? All the possible cases have to be considered. The semantic layer means, do we speak the same language? For example, do we expect the same data units. At last, there are technical issues. Here we talk about standards and technology. I admit, when I was starting my work for interoperability, I thought the topic of all was about data models and the normative use of existing standards. I had to learn more about it. However, for digitalization, we also have to harmonize the underlying processes, which means to follow the 4 layers. When we want to achieve interoperability covering the 4 layers mentioned before, we have to include many stakeholders. This seems to be rather complex. But the positive message is there exists already proven experience to build on. In this context, we see healthcare industry as a pioneer in the field of normative use of standards. There, the IHE was founded because of the problem the healthcare products from different vendors didn't work together, although they used the same technical standard. The Horizon community has developed their governance, which was formalized in a technical regulation at ISO. At first, we started the project IES in the energy sector, which made the first cross-sector knowledge transfer and the adaptation of the IHE methodology. We made the proof of concept for the methodology transfer and the usage of the testing platform and tools in the energy sector. Last year, we had a project IRS in the railway sector, since the methodology of the IEH is in its core sector neutral and therefore applicable for any sector and digitalization issue. With this slide, I just want to show you that from the beginning, we saw the work for interoperability as a European and international issue. In the project IES, we adopted the IEH approach and defined the entire process chain into 3 pillars. Pillar profile. Users and vendors jointly specify use cases and the corresponding data exchange. According to the 4 layers of interoperability, this is done in as much detail as necessary to achieve a normative specification of the interfaces of the corresponding ICT systems. Several use cases that belong to a specific domain are combined in a technical framework, which is the result of the specification process, which is the first pillar. Once the technical framework is released, vendors can use it for the implementation of the interfaces of the ICT systems. The pillar test. Software must be tested to provide interoperability. The tests in this approach are peer-to-peer tests between the ICT systems. You can also test prototypes, since only the communication between the interfaces is tested and not the functionality. In an established organization like in the IHE, they are connected on test events, which last more than 1 week, a whole week. Testing is a very important part of the work and real hard work. The pillar adoption. To run these processes, the goal is to have a community that is process owner and publishes the relevant information, such as technical frameworks and test results. And there's the governance. An organization needs to have rules for their cooperation, responsibilities and decisions. They have to define who can take part in the boards and committees or organizes the test events. Also part of the governance is the entire specification and testing process, described in 3 pillars. Remember, the methodology is formalized in the ISO technical report. In the project IRS, we defined the whole process sector neutral in a white paper. And at the moment, we talk with IEEE to define a standard for a model process for interoperability. Now I come to my example. Now I want to show you the linkage of the 4 layers of interoperability and the IES process for a specific example coming from Austria. The example is in the domain of energy communities and describes how an energy community can get the consumption data from the network operator according to the Austrian legal framework. In Austria, the legal authority e-control determines who has the responsibility for defining the establishment of the data exchange with all network operators. This guideline is one part of the legal framework, and there is the legal layer. The individual necessary processes themselves are defined by EB Utilities, which is organized by the Austrian energy industry. This is corresponding to the operational layer. AB-utility also specifies the XML scheme for the data exchange. This belongs to the semantic layer. And finally, for the implementation of ICT systems, there are the technical issues like the existing standards. Even though it seems that the existing framework and public documentation provides already everything you need for the implementation, the experience showed that implementers have not enough guidance for their work. Remember, we need interoperability among the different vendors, and if there's room for the interpretation of the implementation, we don't achieve it. In this case, the IAS process can start with the available information, identifies the gaps for implementation, and provide a structured approach to extend the existing documentation. The result is a technical framework for energy communities. In the ERANET project Sonder, we specified the technical framework for digital interface for energy communities. For that, we invited implementers from other projects and from companies who intend to implement commercial software solutions for energy communities. Using the experience of the participants in implementing the AB-utility processes, we specified the first integration profiles for the exchange of consumption data. Based on the table of contents, I give you a brief overview how to find the necessary information in the technical framework. At first, there is an introduction to the technical framework. That means how to work with it. For instance, you will always find a Volume 1 and a Volume 2, which both have a specific structure. Volume 1 contains the informative description of the technical solution, which is more than only the interface description. Chapter 1 is the domain overview. Here you find everything you have to know about energy communities and their communication with the network operators. Here you find a reference to AB utilities and a connection to the communication infrastructure. This covers the legal layer. Chapter 2 are the use cases, which is the informative description of what happens and who is involved in the use case. In this example, it's the energy community and the network operator, which is in charge of the metadata infrastructure in Austria. The chapter contains the textual description, an overview of the steps in the use case diagram, and a description of the actors involved. But at this time, we don't talk about technical systems yet. In chapter 3, the integration profiles are described, which is already a more technical description. The integration profiles describe the data exchanges in transactions. The actor transaction diagram specifies the ICT systems which exchange the data and each transaction of the use case. Such a transaction can cover more than a single data transfer. Here, experience and knowledge about the granularity of the specified transactions is very important. This has an impact for the testing later on. Otherwise, not all process steps can be tested correctly. The information flow diagram shows more details about each transaction. These chapters cover the operational layer. Summing up, in Volume 1, you will find everything to understand what happens in this use case and which ICT systems are involved. Then Volume 2 contains the normative specification of all necessary transactions. There, the implementers will find in Volume 2 all they need for their actual work. Every transaction has a normative description of the individual data transfers for the use cases. You see, there's a lot of necessary specification for each step in the transaction. Volume 2 covers the technical layer. Today, XML schemes are often already defined, like in our example from Austria. They can be attached in an appendix, which then covers the semantic layer.